Hello everyone, welcome to the Abhigyan Academy. My name is Sonia Bhattacharya and I'm going to be your geography faculty for the NDA and CDS examinations. Well, before we begin, on your screen you can see we have the list of the students who have cleared the exam successfully and have reached one step closer to their dreams, to their destination in life. And so we encourage you to come and be a part of the Abhigyan Academy as well. Without further ado, now let's begin with our very first geography class. So in today's class, we are going to be talking about a few very fundamental concepts in geography. We're going to be touching upon the fundamentals of geography, which will include latitudes, longitudes, a study of time zones and seasons on Earth. So the first topic that we will try and dissect and understand is latitudes. Now, I believe you all know what latitudes are. Latitudes are basically imaginary horizontal lines that run through the surface of the Earth. So latitude is the measure of how far north or south a point is from the Earth's center, expressed in degrees. As you can see here in this very diagram, we have the Earth and we have these horizontal lines which we have placed all across the surface. Remember, these are imaginary lines. However, these horizontal lines called latitudes help us to understand how far north or how far south a particular point is from the center of the Earth. And remember, the distance is measured in a unit called degrees. Now, due to the Earth's slight flattening at the poles, the distance covered by 1 degree of latitude varies. Remember that the Earth is not a perfect circle, and so towards the poles of the Earth, they are slightly flattened. The structure of our planet is slightly flattened, because of which the distance covered in 1 degree may not always be standard, may not always be the same, and so it varies from point to point. At the equator, which is the prime latitude, which runs right through the center of the Earth, 1 degree of latitude equals approximately 68.704 miles. That is the distance of 1 degree at the equator. However, the minute you move to 45 degree latitude, 1 degree of latitude equals to 69.054 miles. At the poles, 1 degree of latitude covers about 69.407 miles. So this is the variation that you can see of 1 degree. The minute the position changes on the Earth, the measure of 1 degree is also likely to change. So at the equator, the measure of 1 degree is different. At a different angle or a different latitude, the measure of a degree is different, and at the poles as well, the measure of 1 degree varies. However, on an average, 1 degree of latitude is considered to be 69 miles, which is 111 kilometers. If we convert miles to kilometer, remember 1 mile is equal to 1.607 kilometers. But on an average, just remember a quick recap. With each position on the Earth, the measure of 1 degree changes. However, the average that we can take is 69 miles. That can be considered as the standard measurement of 1 degree. So just remember once again, what are latitudes? Latitudes are imaginary horizontal lines that run through the surface of the Earth. And these lines are very important because they actually divide the Earth into different heat zones, which is what we're going to be covering right now. Now remember that the primary latitude that runs through the center of the Earth is called the equator. Now remember that apart from the equator, we also have a few other very important latitudes. So at the North Pole, remember the North Pole is at 90 degrees north and the South Pole is at 90 degrees south. So apart from the equator, there are a few other very important parallels of latitude, which also brings me to a very important point about these latitudes or these horizontal lines. Remember that they are always parallel to each other, which means that they will never coincide at any point. They will never converge at any point. And the further away that you go from the equator, whether you go higher up or lower down south, remember that the length of these latitudes will get shorter because of the circular shape of our planet. Now, the Tropic of Cancer is at 23.5 degrees north of the equator in the northern hemisphere, the northern part of the planet above the equator. Tropic of Capricorn is at 23.5 degrees south of the equator in the southern hemisphere. The Arctic Circle is at 66.5 degrees north of the equator, and Antarctic Circle at 66.5 degrees south of the equator. So this is very important for us to remember, that apart from the equator, there are quite a few other parallels of latitude which are important. So remember, here you can see in the diagram, right in the center at 0 degrees is the equator. Then if we talk about the northern hemisphere, we have the Tropic of Cancer at 23.5 degrees north, and above that we have the Arctic Circle, which is at 66.5 degrees north. And if you come to the southern hemisphere, below the equator, we have the Tropic of Capricorn at 23.5 degrees south, and the Antarctic Circle at 66.5 degrees south. So these are your important parallels of latitude. So remember that if you're enjoying this session, we also do conduct demo classes at the Abhigyan Academy. We've recently just started with our new batch last Monday, and so demo classes are also available. If you want to find out about our teaching methods and how classes are organized, what is our style of teaching, then you are more than welcome to join us for our demo classes as well. Well, let's continue with our course right now. So coming back here, a few important points. Remember that when we're talking about latitudes, the largest latitude is the equator, which I told you is at 0 degree north. And remember that it runs through the center. It runs right through the center of the earth. It's at 0 degree. Apart from that, we have the tropics. Remember, I told you the purpose of these latitudes is to divide the earth into heat zones. So here we have the area, as you can very well see, between this area right here that you can see red, we call this the tropical zone. It's much closer to the equator, and this is the area where we usually have a lot of heat. So remember, the tropical zone is where you have heat surplus, as you can see the area here in red. Then you have the temperate zone, which is the area which has been highlighted in green. Here the temperature is moderate. It's neither too hot, neither too cold. And then if you go further north or further south, we reach the poles. We reach the polar regions, which are heat deficit. That means they are very, very cold areas. Now remember that it is this structure of the earth that is responsible for pressure system and planetary wind systems. So as you can see here, we have once again the important latitudes, parallels of latitude, and how they divide the earth into various heat zones. So as you can see, the area between the Tropic of Cancer and the Tropic of Capricorn is called the torrid zone or the tropical zone. This is the area where you will actually receive direct sunlight, which is why this is the area of heat surplus. It's usually hotter in temperature. So the countries, the places that lie in this torrid zone are usually hot. Then if you go to the areas which lie between the Tropic of Capricorn and the Antarctic Circle, or the Tropic of Cancer and the Arctic Circle, these areas are called the temperate zones, where the temperature is moderate. It's neither too hot, neither too cold. Why? Because the sun's angles, the angle of sunlight here is, remember, it's slanting. It doesn't come directly, it doesn't fall directly. And then if you go to the frigid zones, they do not receive any sunlight at all, which is why they're very cold, and you will even experience -degree temperature. So it's extremely cold, also known as frigid zones. The further up you go, or the further south you go, beyond the Antarctic Circle and beyond the Arctic Circle. So just a quick revision again. The region between the Tropic of Cancer and the Tropic of Capricorn gets the most amount of heat from the sun. Why? Because the angle at which sunlight falls is direct. This is the area between the tropics. Remember, this is called the torrid zone because the sun is directly overhead at least once a year. Now, beyond the Tropic of Cancer and the Tropic of Capricorn, the sun never shines. Kindly remember this. It never shines directly overhead. And so the further we move away, these zones get slanted. The sun rays or the sunlight becomes slanted. And this creates moderate temperature. And so here it's neither too hot, neither too cold. And then The areas close to the poles between the Arctic Circle and the North Pole in the north and the Antarctic Circle and the South Pole in the south are very cold. Here the sun stays low in the sky and its rays are always slanting. And so these regions are called frigid zones because they remain absolutely cold throughout the year. So this is the importance of latitudinal heat zones. Remember, these imaginary horizontal lines actually help us to divide our planet into various heat zones and help us to understand the kind of temperature a particular place will enjoy depending on how close or how far it is from the equator, which will again in return determine what kind of sunlight is it receiving. Is it direct sunlight? Is it slanted? Or is it not going to receive sunlight at all? Now, this is one of the popular questions that comes in your PYQs. Remember the past year questions. This is a very important question. Who among the following was first to state that the earth was spherical? Remember that in the ancient times, it was believed that the earth was flat. And when science was not as advanced as it is today, people also had a lot of superstitious beliefs, a lot of religious beliefs, which is why they thought that because of the sins of the world, the earth was too heavy and Alright, just coming back to this, who among the following was first to state that the earth was spherical? Like I said, it was earlier believed that the earth was flat, but the first person to have actually brought this suggestion that the earth is spherical or round in shape is none other than Aristotle. So the right answer to this question would be Aristotle. Now let's come to the next part. We've already covered latitudes. Let's now come to longitudes. Remember, latitudes are horizontal. There are also now vertical lines that run through the surface of the earth. Again, these are imaginary lines. These vertical lines are called longitudes. They give you an understanding of the measure of distance in degrees and east or west of the prime meridian. If the equator is the prime latitude, remember that the prime longitude is the prime meridian. Remember, meridian is another word for longitudes. On a globe, longitude lines are shown as semicircles that go from the North Pole to the South Pole, passing through the equator. Okay, that's how they are drawn. The prime meridian is at 0° longitude and it runs through the Royal Astronomical Observatory at Greenwich near London. So this is actually the point which is very important, that the prime meridian actually runs through the Royal Astronomical Observatory at Greenwich near London. So this is absolutely important, and that's why the time of every other place is calculated by comparing the distance of that place in relation to Greenwich near London. Okay, so this is the international standard time, the Greenwich mean time, and considering how far or near a place is to Greenwich, we are able to determine the time of that place. Which brings me to the primary point, that if latitudes help you to understand heat zones, longitudes help you to understand time zones. They help you to understand time in a particular place in our planet. All other meridians or lines of longitude spread out from the prime meridian going both east and west up to 180 degrees. Meridians get closer together near the poles, just like the lines of latitude get shorter. So this is a very important point. Remember, I had mentioned the further away you go from the equator, latitudes get shorter. Similarly, remember that also for longitudes, they tend to converge because they are not lines per se, but they're actually semicircles that are drawn. And so they tend to converge at the poles. They get closer together near the poles. One important job of longitude lines is to help us figure out the local time compared to Greenwich Mean Time, also known as the world time. The international date line is directly opposite to the prime meridian at a longitude of 180 degrees. So the primary reason or the primary purpose of meridians or longitudes is to help you understand time and to help you understand date of a particular place. So when it comes to the time, it is this prime meridian that runs through Greenwich that will help you to understand time. And when we're talking about the date of a particular place, it is the international date line that is directly opposite to the prime meridian that will help you to decipher what date is it in a particular place. I believe you're all with me and you're all understanding as I'm teaching you. So as you can see here, these are semicircle like lines that are drawn, okay, and they go from the north to the south. They are measured, they help you to understand how near or far, how further east or how further west a particular place is. And at 0 degrees is the prime meridian, right? At 0 degrees is the prime meridian. So remember, angular distance of a place from prime meridian, also called meridians. Remember, longitudes are also called meridians. At 0 degree, we have Greenwich in UK. And 180 degree, which is just at 180 degree of the prime meridian, at the exact opposite side of the prime meridian, you will find the international dateline, which we will do in details shortly. So once again, we have a lot of students who have joined the Abhigyan Academy. Just to remind you, we were established in 1992, and so far we've had a record of successfully helping at least 4,400 students clear their NDA and CDS exams, and today many of them are in very good positions in the defense forces. And so we invite you to come and join us, come and be a part of the Abhigyan Academy, where we strive for nothing less than excellence. So continuing again with our course, remember, as I've mentioned earlier, longitude helps you to understand time. Latitude helps you to understand the heat zone or the temperature of a particular place, but longitudes will give you an idea about time. Now remember, the Earth completes a rotation, a 360-degree rotation, in a time of 24 hours. So if we divide 360 by 24, we get 15 degrees, which means that every 1 hour, the Earth actually covers a distance of 15 degrees as it is rotating on its own axis. Remember, 15 degrees is covered every 1 hour. So, or 1 degree is covered every 4 minutes. This is a very important point. This is what we need to remember so that we are able to calculate the time of any given place. Now remember that the Earth always spins from west to east. So moving 15 degree adds 1 hour to local time, while moving 15 degree westward subtracts 1 hour. So this is what you have to remember. Whenever you are moving east of Greenwich, you are going to gain time. And if you're going to move west of Greenwich, you are going to lose time. Because why? Apparent sunrise is always from the east to the west. So if you go eastwards, you're going to be ahead in time. And if you're going to go westwards from Greenwich, you're going to be behind time, or you're going to lose time. Now remember, places to the east of Greenwich see the sun earlier and gain time, which I've already mentioned, while places to the west see the sun later and lose time. To find local time from Greenwich Mean Time, we add or subtract the difference based on the given longitude. So the minute you're able to get the longitude of a particular place, we're actually able to calculate what could be the time in that space. Now the graticule, this is important here. We have the graticule. Graticule is a network of latitude and longitudinal lines on a globe helping to pinpoint locations. Okay, so remember, there's actually a network. There's actually a network of lines, of horizontal and vertical lines, and that network is what you call graticule, and they help you to pinpoint a location on the globe. Great circles are imaginary lines that divide the Earth into equal halves and have their center at the Earth's center. So the largest great circle on the globe is naturally the equator, and all the meridians or all the longitudes. So this is the fact, or this is the point that we really need to remember, because for all the examinations, when it comes to calculating time, this is what is going to help you. Remember that 15 degree is covered in every 1 hour, and when we're talking about 1 degree is covered every 4 minutes. Because of the Earth's rotation, the pace at which the Earth rotates. Now we also have something called the international dateline. Now remember that the international dateline, when traveling east from Greenwich, a person gains time until they reach 180 degree meridian, where they'll be 12 hours ahead of the Greenwich Mean Time. Traveling west from Greenwich, a person loses 12 hours when they reach the 180 meridian. So there's a total time difference of 24 hours or 1 day across this meridian. So if you're talking about the international dateline, which you can see here, it's zigzag in nature. Why is it zigzag in nature? I'm going to teach you that shortly, but just remember that the international dateline, which is the exact opposite of the, lies at the exact opposite end of the Greenwich or the prime meridian. Remember that it's zigzag in nature and it actually passes through, again, the center of the earth. And on either side of this international dateline, there's a time difference of 24 hours. Okay, there's a total time difference of 24 hours or 1 day. The minute you cross from one end to the other, you go from east to west or west to east, you are actually going to be either ahead by 1 day or you're going to be behind by 1 day. The international dateline is located at 180-degree meridian. Crossing it changes the date by 1 day. Remember that it immediately brings a change of date. Traveling east across, you will gain 1 day. You've gone ahead by 1 day if you go eastwards of the international dateline. And if you come towards the west of the international dateline, you are going to lose an entire day. In the Pacific Ocean, the international dateline curves away from the straight 180-degree meridian near places like the Bering Strait, Fiji and Tonga. This prevents confusion in islands where the meridian passes through, ensuring consistency in the day and date. So I'm going to explain this to you in a more simple manner. As you can see here, this is the international dateline. The prime meridian is a proper semicircle, or it looks here on this 2D surface, it looks like a straight line. However, the international dateline is not a straight line, it is actually zigzag in nature. The reason why it's zigzag is to avoid confusion. Now remember, I've already mentioned that the minute you cross the international dateline, you're either going to be ahead by 1 day or you're going to be behind by 1 day. That means you will either gain 24 hours or you will lose 24 hours. Now, there are certain islands which are a part of the same island, but certain portions, if the international dateline is considered to be a straight line, then certain portions of the same island can fall on the east of the international dateline and certain portions can fall on the west of the international dateline, which means that in the very same island, they're going to experience two different time zones, right? The east is going to be 1 day ahead while the west is going to be 1 day behind. However, they are a part of the same island. So now that becomes really confusing, where in the same island, you have two time zones. So in order to avoid this confusion, we actually have a curved dateline so that we're able to incorporate all the parts of the island on one side of the international dateline so that they all can have the same time zone. They all can have the same date zone, okay? Their dates don't change, but they remain constant. Because otherwise, if it was a straight line, remember the same island can be divided into two halves and they can have different time zones. They can have two different dates, which is going to be very, very confusing. So in order to avoid this confusion, the international dateline has not been kept a straight line, but it's actually been made zigzag. So that you can accommodate the entire island in this curve, and the entire island can follow the same date and the same time to avoid confusion. So this is why the international dateline is drawn in a zigzag manner. Remember, it passes through the Pacific Ocean. It's an imaginary line like longitudes and latitudes. The time difference on either side of this line is 24 hours, which I've already mentioned. So the date changes as soon as you cross the international dateline. If you cross it to the east, you're going to gain 24 hours. If you cross towards the west, you're going to lose 24 hours. Now remember that certain groups of islands, for example, Polynesia, Melanesia, Micronesia, they fall on either side of these datelines. So if I'm going to draw it as a straight line, as I've mentioned, you're going to experience two different time zones on the same island. And in order to prevent this confusing scenario, remember the international dateline has been drawn as a zigzag so that in the curve of the international dateline, you're able to accommodate all parts of the island, and the entire island as a whole can actually follow the same date and the same time zone. So this is exactly what is written. If the date line was straight, then two regions of the same island country or island group would fall under different date zones. Thus, to avoid any confusion of date, this line is drawn through where the sea lies and not land. Hence, the IDL is drawn in a zigzag manner. So this is basically to avoid confusion so that groups of islands or island countries can enjoy and follow the same date zone and the same time zone. So if you're enjoying this class, again, we invite you to come and be a part of the Abhigyan demo classes. You can feel free to contact our office and take a demo class, see how our faculty is, see how we interact with students. And if it suits your palate, if you feel like this is something you can continue with, then we welcome you to come and be a part of the Abhigyan Academy. Now, these are some of the questions that usually come, some PYQs. For example, the shape of the earth is geoid. The region that lies between the Tropic of Cancer and Tropic of Capricorn is called torrid zone. The temperature decreases from equator to poles because of the shape of the earth, and North Pole is a latitude. Now, these are some of the important PYQs that usually come. So, for example, in this case, which statements above are true? Is the earth geoid in shape? Yes, it is. The region that lies between the Tropic of Cancer and the Tropic of Capricorn is called torrid zone. Yes, it is. The temperature decreases from equator to poles because of the shape of the earth. Now remember that this one is not absolutely right. This is because of the angle at which, of course, the sunlight falls, but this is also because of the circular shape of the earth, because of which naturally our sunlight falls on an angular or slanted angle. The higher up you go, the further you go from the equator. So this is absolutely right, actually. And then you also have the North Pole as a latitude. So here you see 1, 2, and 3 are right statements. And the fourth one, North Pole is a latitude, is also true. So actually all 4 statements are true. All 4 statements are true. Which of the following statements is false? Both longitudes and latitudes are necessary to determine time and location. Both longitudes and latitudes are necessary to determine a location. GMT is a reference time zone. All other time zones make use of GMT to specify time at a location. It's correct. Places to the east of Greenwich gain time, while those to the west lose. This is correct. So the false statement here is longitudes and latitudes are necessary to determine time at a location. It's just longitudes that help us to determine time. But yes, longitudes and latitudes do help us determine a location, pinpoint a place. And then we also have GMT, which is a reference time zone. It's correct. And losing time and gaining time east and west of Greenwich is also a true statement. So the false statement is number A. And then we also have one more question. A person traveling from Japan to USA across international dateline will gain a day. A person traveling from Hawaii to New Zealand across international dateline will lose a day. It is not convenient for a country of greater latitudinal extent but smaller longitudinal extent to have multiple time zones. On a 24-hour clock, the time is 12 in London. Then the time in Mumbai on a 12-hour clock will be 5:30 a.m. So this is what we need to calculate using your longitudes and latitudes. Now remember this, standard time of a country is the local time of a specific longitude passing through an important place in that country. So this is how we determine the standard time of a particular country, the longitude that passes through a particular place in that country, considering the time in that longitude. For example, in India, we consider New Delhi. So each country chooses its own standard meridian. We all choose our own standard longitudes. The angular distance between a country's standard meridian and the Greenwich Mean Time determines its time zone, which we're going to calculate shortly. For instance, India's standard time is based on the longitude passing through Allahabad, which is at 82.5 degrees east of the prime meridian. This means India's time is 5.5 hours ahead of GMT. So just a clarification here that when it comes to India, the longitude that passes through Allahabad is what we consider to be our standard time. And so remember that India is 5.5 hours ahead of Greenwich. Why? Because we are in the east of Greenwich. So we are going to gain time. And so we're going to be ahead. We are at 82.5 degrees east. A simple rule to remember is we lose 12 hours to the west of the prime meridian and we gain 12 hours to the east of the prime meridian. Remember, whenever you go to the east, you gain time. Whenever you go to the west, you lose time. So now this is an important question. If it's 12 noon at Greenwich Mean Time, what is the time at 30 degree west? Now remember that we are going 30 degrees west of Greenwich. So if you're going to the west, first thing you have to be clear about is that you're going to be losing time. That means you're going to be behind time. Now remember that if 15 degrees is equal to 1 hour, 30 degrees, if you naturally multiply it, it's going to be 2 hours, which means that this particular place, which is at 30 degree west of Greenwich, is going to be 2 hours behind Greenwich. So if the time at Greenwich is 12 noon, the time at this particular place at 30 degree west is going to be 10 a.m. Now, if it's 12 noon, let's try another PYQ. If it's 12 noon at GMT, what is the time at 75 degree east? Now remember, if we're talking east, then we're naturally going to be gaining time. So if it's 15 degrees, remember, if every 15 degrees, we gain 1 hour. So if we're talking about 75 degrees here, you understand it's 5 hours, right? So if you keep adding 15 plus 15 plus 15 plus 15 plus 15, you get 75 degrees. So we are going to be ahead by 5 hours. So this particular place, which is at 75 degree east, is going to be 5 hours ahead of GMT. And so the time here is going to be 5 p.m. Let's now go to another very important concept in geography, which is land breeze and sea breeze. Now, a few very important things that we need to remember here is that land has a very unique quality. It heats up very quickly and it cools down very quickly as well. So during the day, land is going to heat up faster than the sea, and during the night, land is going to get cooled down faster than the sea. This is a unique property of land. And also remember another very important point, that wind will always tend to move from an area of high pressure to an area of low pressure. These are the two fundamentals we need to remember whenever we are understanding land breeze and sea breeze. The first thing that we need to understand when we're talking about sea breeze is, what is sea breeze? Sea breeze is a coastal wind. Okay, coastal wind, that means it's coming from the coast, it's coming from the sea, it blows from the sea toward the land, and this occurs during the day. It is caused by temperature difference between the land and the sea. So as I've mentioned, that the land heats up very fast. So during the day, the land heats up very quickly. And because the land heats up very quickly, the air above the land also gets heated up. Now when it gets heated up, remember, anything that becomes hot, its density begins to decrease. And if its density begins to decrease, its pressure also gets lower. So if the temperature is high, the pressure is going to be low. Exactly opposite happens on the end of the sea. The sea is much cooler during the day, and so the air above it is also cool, which is why the density is higher and the pressure is higher. Remember, I told you that wind always has a tendency to move from area of high pressure to low pressure. So during the day, because of this temperature and pressure difference, a pressure gradient is created, because of which during the day, the wind, the breeze tends to move from area of high pressure to low pressure. So since sea area has higher pressure, the wind will blow from the sea towards the land. That is what we call sea breeze. It's a very basic, very important concept. Remember that the first thing that happens is temperature difference. The warmer air over the land rises, creating an area of low pressure. Meanwhile, cooler air over the sea remains dense, and so it creates a zone of high pressure. And so a pressure gradient or a pressure difference is created where the area above the land is low pressure and area above the sea has high pressure. And like I've told you, that wind will always blow from high pressure to low pressure. So during the day, the wind blows from the sea towards the land. See, wind blows from areas of high pressure to areas of lower pressure, resulting in a breeze that blows from sea toward the land. Why? Because of temperature and pressure difference. Now, speed and strength, remember, sea breezes are typically stronger and more noticeable than land breeze because the temperature difference between land and sea is greater during the day. Land is much hotter and sea is cooler in comparison. Because the temperature difference is much greater during the day, sea breeze tends to be more noticeable and more intense. Timing this usually begins in late morning or early afternoon, reaching their peak strength in the afternoon and weakening in the evenings as the land starts to cool down. Remember, the land will always cool down faster than the sea. It also heats up faster than the sea. Now, sea breezes have various effects, including cooling coastal areas during hot days, influencing local weather patterns and affecting activities such as sailing, surfing, and kite flying. So these are a few very important effects of sea breeze. So you can see here, during the day, the land becomes hot and the air above the land also becomes hot. Area of low pressure is created. High temperature means low pressure. And so the air begins to rise. And then you have, on the other hand, towards the sea, it's much cooler. And so because of which it's more dense, and so it's high pressure. And wind will always blow from high pressure to low pressure area. So during the day, the wind is going to blow from the sea towards the land. So this is what you will call a sea breeze. Now, the exact opposite happens during land breeze, but before that, another reminder that you're just a few steps away from your dream, and so we invite you to come and be a part of our academy, enroll in the NDA and CDS course. We are specifically customized and we are specifically focusing only on the defense examinations. So if that's your dream, if you want to make your parents proud, you want to be a part of the armed forces, come and be a part of the Abhigyan Academy. Now, coming back to land breeze, remember that again, the concept here is the same: temperature difference and pressure difference. So when you're talking about land breeze, this occurs during the night when the land cools down much faster. Now, when the temperature is low, remember the air is going to be more dense, and when it's going to be dense, it's going to be an area of high pressure. Now, on the other hand, the sea is already much warmer compared to the land, and so the air above the sea is warmer, and so remember, the air is less dense, and so there's low pressure. So since wind always blows from area of high pressure to low pressure, during the night, because of the pressure gradient, the wind is going to blow from the land towards the sea, area of high pressure to area of low pressure. So this is what you call land breeze. So again, this occurs due to temperature difference between land and sea at night. Land cools down rapidly in comparison to the sea. So remember, as the land cools, the area above it also cools, creating an area of high pressure over the landmass. And then air movement always happens from high pressure to areas of low pressure. So this movement of air from land to sea is what creates the land breeze. So the direction is land breeze typically blows from the land towards the sea. This is the direction opposite to the direction of sea breeze, which always blows from the sea to the land. Now remember that land breezes are more gentle and stable in comparison to sea breezes. They tend to be stronger and more predictable during the night when temperature differentiates are most pronounced. Effects are: land breeze have effects on local weather patterns such as cooling coastal areas and affecting marine activities like sailing. These are a few of the effects of land breeze. And remember, formation: land breeze usually starts to develop shortly after sunset as the land begins to cool down, and they continue to go through the night until early morning, when once again the land starts to warm up with the sunrise. So this is the concept of land breeze. As you can see here, during the night the land has become cooler, and so because it's become cooler, the air above has become more dense, and so there's an area of high pressure over here towards the land. Towards the sea here, the land is much warmer, so the air above the sea is of a lower density. Since it's of a lower density, it's low pressure. And remember, so above the land is high pressure, and above the sea is low pressure, and wind always blows from high pressure to low pressure. So at night, the breeze will go from the land towards the sea. So this is the idea of land breeze. So with that, we've come to the end of our class for today. I hope you understood the concepts. Now remember, we have a very interactive class, so if there are any doubts, you're always more than welcome to have your questions asked to the faculty. And if you did enjoy this online teaching session, then come and take a demo class with us in person. Come and see how we actually interact with the students and be a part of the Abhigyan Academy, where excellence is our priority.